got emailed a couple of problems from 6.4. And I think what's the issue with these is that they're just really big numbers. So you'll have to just be very careful with your factoring. You'll need to use the key number method to look for a greatest common factor, but I don't see one. So I would take the 35 times negative 54 here. So that's negative 1890, and then just be methodical and go through and find what numbers multiply. You'll need a negative times a positive to get a negative. Just keep working it out. So I'm not going to keep writing each one down, but you can see I just keep going through the list. 1, 2, 3, 4, 5, 6, 7, and so on. I'm up to 27. I have negative 27 times 70. No, that adds to 43. Okay. Here we go. Negative 30 and 33. I mean, negative 30 and 63. I was like, why was that helping me? Negative 30 and 63, that adds to positive 33, so I'll negative positive 30 and negative 63. So then we're going to split up. We split this up into plus 30xy minus 63xy. We do the same thing with the next one. So the key number there, 9 times 25, or negative 9 times 25. So that is negative 45 times positive 5. So I'll split that numerator up. So you split up the inner and outer terms, and then you can factor by grouping. So you look at this as two sets of two terms. So the greatest common factor on the first two terms, that would be 5, 5x. And the greatest common factor on the second two terms would be negative 9y. In the second numerator, the first two terms you can factor off a 5x. On the second two terms, you can factor off a y. Now don't cancel here, okay? It's tempting to cancel, but you still have factoring going on. You still have to factor the 5x minus 9y off of each of these, and the 7x plus 6y off of each of these. But now you have all multiplying. See, everything's in a parentheses ready to multiply together, so now you can cancel matching pairs of binomials. So does everything cancel? Let's see. We get 1. So I would try just putting 1 in on this answer, unless you want some practice at factoring. The next one, I think, is already set up for factoring by grouping. So the next one, number 17, is easier to factor by grouping. Because it already has 4 terms. So we'll go ahead and invert and multiply that second fraction. So dividing means flip over that second fraction and change to multiplying. And then after we do that, we'll factor and cancel. You know, I see a greatest common factor on this first numerator is a y. So let's just factor off a y while we're doing this, okay? So y times x, y, minus y, plus 5x, minus 5. There's a greatest common factor of y on this denominator that I'm flipping to put in the numerator. So I'm going to factor that off while we write it down. And in the numerator, there's a greatest common factor of y squared. So I'm flipping that, and it's in the denominator now. So let's get the y squared factored off. So we invert and multiply, and also factor off some powers of y. So the y's can actually cancel. You see how we have multiplying going on? Everything that's a sum or a difference I put in parentheses, and you can't cancel part of those sums and differences. But the y and the y squared, they're a part of the product. They're multiplying. Everything's all multiplying, and so I can cancel the y and y squared. And then keep factoring the 4 terms here. Okay, so the greatest common factor on the first 2 terms is y. Greatest common factor on the second two terms is 5, which is not equals, plus. In the denominator, the greatest common factor on the first two terms is y, and on the second two terms, 5. The second numerator, the greatest common factor is y. On the first two terms, on the second two terms, it's 7. In the denominator, first two terms, we can factor off x. And then the second two terms, you can't factor anything off, so you can put a 1 parentheses y plus 7. So now I'm back to having sums and differences. So now I wouldn't cancel anything, okay? Because now I have pluses in the middle of my numerators and denominators. But that's okay because we're not done factoring by grouping, right? So now we write x minus 1 times y plus 5 and x minus 3 times y plus 5. And x minus 3 times y plus 7. And y plus 7 times x plus 1. Okay, so we're all factored, and now we can cancel common factors. So this one is x minus 1 times x over x plus 1. Let's see what other questions I got asked. Let's do number 8. We have to find f of x plus g of x. So we're going to add the two functions together. And when we do that, we'll need to have a common denominator. So we should work on factoring the denominators. These numbers aren't too bad. So I'm going to show you some guess and check, okay? The key number method is hard, and I wanted you to learn that because you do have problems with big numbers, and you will have a problem, at least one on the test with big numbers, and that needs practice. But guess and check is nice when you have smaller numbers, like this 1, for example. The only way to multiply and get a 1 is a 1. And we could use the key number method on that, but guess and check, you think, well, to get a negative 1, I have to have a positive 1 times a negative 1. And then the 5x squared would come from the first terms. So those would have to be a 5x times a 1x. And the guessing is, does the 5x go here and the 1x here, or the other way around? So that's the guess. And then you check by using FOIL. So first terms, 5x squared. Outer terms, negative 5x. Inner terms, positive 1x. And last, negative 1. So I do get the negative 4x, so my guess was good. Okay. And same thing with the second fraction. We can use guess and check because the numbers there are not too bad. We have to have a 5x times a 1x to get 5x squared. But now negative 7, that's also has to be a 1 times 7, and one of those needs to be negative. So we got to figure out, do I put the 1 here or the 7? You know, what goes what? So you'd put it down, and then you'd guess, and then you'd check. So you multiply it out. 5x times 1x is 5x squared. Outer terms would be 5x times 1, so 5x. Inner is negative 7x, and last, negative 7. So this was not a good guess, because the 5x and negative 7x add to negative 2x, not negative 34x. So let's change those around. Put the 7 here and the 1 there. And then check again. Okay, so first term's 5x squared, outer terms 34x, inner terms negative 1x, and last negative 7. So I'm almost there. Oops, I said 34 and it's 35. I'm almost there. That adds to positive 34x, so I just have to change my signs around. So we have a plus and a minus. So the advantage of the key number method is that if you have really big numbers, you for sure will find your answer if you just are careful and don't miss any as you go through your list of dividing. The advantage of guess and check is it's faster if you have some prime values that are easy to work with. Okay, so anyway, we have our denominators factored. So let's build up the numerators and denominators so that we have the least common denominator. So fractions have to have the same denominator to be added together. So just write one of the denominators down. And then add to that whatever is missing. So the second fraction has a denominator 5x plus 1 times x minus 7. So I have to write the x minus 7 yet in my least common denominator. So in my first fraction, we'll go ahead and build it up. We'll multiply by x minus 7 over x minus 7. So it will have the least common denominator. The second fraction will build up by multiplying by x minus 1 over x minus 1. So distribute in your numerators, but leave your denominators leave your denominators in factored form. So we get 5x squared minus 35x and 20x minus 20. And now you can add the numerators together. So we have 5x squared, and then negative 35x plus 20x, that's minus 15x, minus 20. And now I have a greatest common factor of 5, so I wonder if I can factor and reduce this. It kind of looks like I maybe can. So if I factor off of 5, then I have a trinomial that factors as x minus 4 times x plus 1. So I can't reduce. I was thinking maybe the x plus 1s would cancel, but nope, not going to happen. Well, I think we'll get on with today's work. A lot of you emailed me, and I'll try and get some problems in after this as well. But for now, we'll go on and work on today's work, okay? So do be practicing. I don't think there's enough homework for people who don't do very well at math. I think there's probably enough homework if you're pretty good at math. But you need to practice extra if math isn't your thing, okay? So go to the textbook and work problems from the textbook. The solutions are in the back of the textbook and the appendix. I think I have a solutions manual for this text at the library desk, at the reserve desk, okay? So solutions manual. That's on the 3rd floor. You just ask for the solutions manual, and they'll ask you what class you're in, and then you tell them, and then all the problems are worked out. So practice extra, okay? The exam is hard compared to the first exam, just because the material is harder, so you do need to practice more for most people. Okay, let's take a look at 6.5, complex fractions. So we talked about dividing fractions and how when you divide a fraction by a fraction, you invert and multiply. And the reason we do that is because you can take your fraction and multiply the numerator and denominator by the flipped fraction from the denominator, 7 over 1. And when you do that, in the denominator, you just get 7 sevenths. Well, 7 sevenths is 1. And so you end up just having 3/5 times 7 over 1, 21/5. So you can multiply the numerator and denominator of a fraction by the same amount, and you're just multiplying by 1. And so that's why inverting and multiplying works. So we don't usually show the bottom, we just show the inverting and multiplying. So here we'll just leave the x over y and flip y over x plus 3. And so as you multiply fractions, you multiply straight across. Remember, multiplying and dividing fractions is easier than adding and subtracting. You just multiply straight across the top and straight across the bottom when you multiply. Don't actually distribute, instead reduce. Now when we're adding, we distribute it in the numerators, okay? Because you're adding the numerators up, and you can't do that till you distribute. But when you're multiplying, don't distribute, because we're always hoping for some reducing going on. So here we would have a over b minus c, and then we'd flip the bottom fraction over, put the b minus c over d. And those sums and differences go in parentheses. And then you just multiply them together, but the b minus c's cancel. So you just get a over d. In fact, you could cancel way back here. Same thing up here. You could cancel way back here. You don't have to show that step of putting the factors in one numerator and one denominator. Now there's 2 ways to simplify complex fractions. So this page, we'll use method 1. Okay? This description is method 2. I used to just teach students method 2 because it's hard to do 2 methods for things. You get mixed up, like, which am I doing? But on WebAssign in the solutions, when you go, practice another version and then you look at the solution, they usually use method 1. So I want you to know, what are they doing there, okay? So method 1 is to multiply every term by the LCD of the little fractions. So look at your little fractions. You have a y in this denominator. You have a 3 times y in the second denominator, and then you have a y in the bottom little fraction. So the least common denominator of all of those is the smallest product that contains each denominator. So 3 times y contains the y and the 3y and the other y. You don't have to have them individually. You just have to be, they just have to be in there. Okay, so you have the 3 times y. Okay, so multiply every single term by 3y. Just going to multiply 3y, 3y, 3y. Notice when you do that, what you're doing is you're multiplying by 3y over 3y. So, so you're really just multiplying the top by 3y, but it distributes. So you're not multiplying by like 9y squared. You're multiplying by 3y, but it distributes. Maybe I should have showed that. Here, I'll show that. But in practical terms, when you're actually doing your homework, then you put 3y times x over y plus 2 times 3y over 3y, and then 2 times 3y over y. So what you have going on then is you have 3xy over y plus 6y over 3y, and then 6y over y. So the 3y you're multiplying by is like, it's like a 3y over 1 and a 3y over 1. So the 3y you're multiplying by just ends up in the numerator of each term. So these all reduce. The point is these all reduce. So your y's cancel and you get 3x, and your y's cancel and your 3's cancel and you get 2, and your y's cancel and you get 6. So these directions are for method 2. We're using method 1. So method 1 is when you have a nice, relatively nice least common denominator, and you can multiply each term by that least common denominator, and you're multiplying in each term's numerator. So when you multiply the top and bottom by the 3y, that's just multiplying by 1. But you pick the 3y so that as you do that, each denominator in those little fractions divides away. Does anyone have questions? So look at these little denominators. You have a c. What is 2's denominator? 1. Good. And then another c, and then a 3c. So the least common denominator, that's 3 times c. So the least common denominator is the smallest product that has each denominator within it. So we need the 3 times c, and then this c is inside of there, and this c is inside of there. And if you want, you can put 1 times 3 times c. And you notice you still get 3 times c, so you don't have to put the 1 there. So multiply every single term by 3c. So every single term gets multiplied by 3c, and the 3c you're multiplying by goes in the numerator of those terms. So you have 9abc over c plus 6c over 1. You didn't really have to show the 1, but I just was trying to clarify your fraction. And 3c over c, and 3bc over 3c. So when you do that, your fractions reduce. Your c cancels here, so you have 9ab. There's nothing to reduce there, you just have 6c. The denominator, the c's cancel, so you have 3. And in the second term, the 3 and the c cancel, and you have b. So the first method is to multiply every single term, even the ones that aren't fractions, by the least common denominator. And when you do that, you pick your least common denominator because now your denominators divide away. we should put reduce. I was trying to think what steps you could write in that you took. Okay, so you multiplied every term in the numerator by the least common denominator, and then you reduced every term. So use method 1 for relatively nice denominators. We're going to use method 2 on the second page because your denominators are sums, and they're not even the same sum. It wouldn't be so bad if like these were all x plus 2s or all x minus 1s, but they're not. Okay, so use method 2 when denominators are sums. Remember, a sum can be subtraction because we can add negatives. Okay, so let's look at the directions for method 2. First, we combine the fractions to attain a single fraction in the numerator and a single fraction in the denominator. Then, invert and multiply the denominator. Okay, so you're not going to work on the whole fraction at a time. You're just going to work on the top or the bottom to get one fraction over one fraction. And then you'll invert and multiply. So these are method 2. Okay, so the first page is all method 1. So this was method 1. Both were method 1. And now we're doing method 2 on this page. So on the numerator, you're just going to get a least common denominator for these two little fractions and add them up. So what would be the least common denominator for these two little fractions? Go ahead. K times k plus 3. So that's for the little fractions in the numerator. Okay, so we build up those two little fractions. First, we'll take the 1 over, oh, that's a j. The j over k plus 3 and multiply by k over k. And the 1 over k will multiply by k plus 3 over k plus 3. So this is the kind of work we were doing in 6.4, where you're adding fractions after they have the same denominator. So that's exactly what we're doing. We're treating the numerator like two fractions being added together. So your first numerator is kj. You have kj over k times k plus 3. And then the second numerator is k plus 3. So k plus 3 over k times k plus 3. And we didn't do anything with the denominator because we're using method 2 and we're just working to get a single fraction on the top. Well, now the two little fractions on top have the same denominators, so you can add their numerators together. So you have kj plus k plus 3 over k times k plus 3 all over 5 over j plus n. So now you can go ahead and flip the bottom fraction over and multiply it times the top fraction. So leave the top fraction the way it is, kj plus k plus 3 over k times k plus 3. And then we flip the bottom fraction over, so j plus n over 5. So when you're multiplying fractions, you put sums in parentheses, And hopefully that helps you remember, don't cancel part of a sum. So we have kj plus k plus 3, parentheses, times j plus n in the numerator. And the 5 you can put in front of the k. You don't have to, it just is typically put there, okay? So 5 times k plus 3. So the second method is when your denominators are sums or differences. You just get the two little fractions in the numerator added together, and then you can flip the bottom fraction over and multiply times the top fraction. So that's a method we'll use on the next problem as well. Does anyone have any questions? Nothing really reduced here, so we'll just leave that the way it is. Okay, so in the numerator, the least common denominator in those little fractions, what would the least common denominator be, because we're using method 2? Good. X plus 2 times x minus 1. So the least common denominator is the product of the two denominators. So we're going to build up those two little fractions and add them into a single fraction. So let's see, the first fraction needs an x minus 1 in its denominator. So we'll multiply by x minus 1 over x minus 1. So I'll put little parentheses around the x plus 2. And then the second fraction needs an x plus 2. So we'll multiply the x plus 2 over x plus 2. Put little parentheses around the x minus 1. So in the numerators, we multiply out because we want to do the, in this case, subtraction. You want to do the adding or subtracting. So here we get 2x minus 2 over x minus 1 times x plus 2. And then the second numerator, we multiply out, we get 3x plus 6 over x minus 1 times x plus 2. And that's all over x plus 2. So those two fractions on top now have the same denominator, and they can be subtracted. So we have 2x minus 2 minus 3x minus 6 all over that least common denominator, x minus 1 times x plus 2. So the minus sign distributed, so you have a 3x, a minus 3x, and a minus 6. So we have negative x minus 8 over x minus 1 times x plus 2 over x plus 2.
Wait, I'm confused. Isn't it supposed to be plus 6 in the second one?
So it was a plus 6, but then this minus distributes.
Oh, okay.
So it's minus. Any other questions? Okay, so we have one fraction on top, and then the x plus 2 in the bottom. So it's time to invert and multiply. How do I invert and multiply? I don't have a fraction.
It's over 1.
Yeah, good. So think of the x plus 2 as over 1, and then you can flip and multiply that way. So we invert and multiply, and the x plus 2 ends up in the denominator. So I should have started out by saying what a complex fraction is, because that's what the chapter's titled. A complex fraction is when you have a fraction inside of a fraction. And we don't want to leave fractions inside of fractions. It's difficult to read. So we simplify complex fractions, and we have these two methods to do that. One is to work with, method one was to just find the least common denominator in the whole problem with all the little fractions and multiply every single term by that. And that's easiest to do when you have denominators that are just products, fairly simple products. When you start getting sums in your denominator, then it's often easier to just use method 2 and get one fraction on the top by getting a common denominator for the little fractions and adding them up. And then one fraction on the bottom and flipping and multiplying. Now, either method can be used in any problem. Anytime you use method 1, you can also use method 2. It's just one might be easier than the other. So here, for example, I have relatively complicated denominators, x plus 3 and x minus 3. So I think I'll go ahead and use the method 2. So what would be the least common denominator for these little fractions? Exactly. X minus 3 times x plus 3. So let's go ahead and build up the little fractions. We'll multiply by the first fraction by x plus 3 over x plus 3. And the second fraction by x minus 3 over x minus 3. Now this time we have a sum of fractions in the denominator, so we have to have the same technique going on in the denominator. Once you pick a technique, that's the technique we stick with. So now I have to build up the fractions in the denominator. They do have the same least common denominator, so I'll multiply the first fraction by x plus 3 over x plus 3. And I'll multiply the second fraction by x minus 3 over x minus 3. Put little parentheses around our sums. So when we're adding fractions together, you distribute the numerators, but leave the denominators in their factored form. We distribute the numerators, though, so that we can actually do the adding or subtracting. So in the numerator, I get x squared plus 3x in the first fractions. And then in the second fraction, I get x squared minus 3x. In the denominator, distributing 3x, that gives us 3x squared plus 9x. And in the second fraction, we get x cubed minus 3x squared. So we build up the little fractions so they both have, both the ones that you're adding or subtracting have the same least common denominator. And then in the numerator now we'll go ahead and subtract. So that minus will distribute. You'll get minus x squared plus 3x. So in the top we have x squared plus 3x minus x squared plus 3x over x plus 3 times x minus 3. In the denominator we have 3x squared plus 9x plus x cubed minus 3x squared. So we're working to get one fraction on top and one on the bottom, and we're almost there. Well, we do have that. We're just going to simplify them now. So we have 6x over x plus 3 times x minus 3. And x cubed plus 9x over x plus 3 times x minus 3. So you get one fraction on the top and one on the bottom, and then you can invert and multiply. So that's our next step, invert and multiply. Oops, I have to write smaller. So we have a 6x over x plus 3 times x minus 3. And then flipping over the other fraction, we have x plus 3 times x minus 3 over x cubed plus 9x. So put parentheses around your sum. Don't cancel part of a sum. Okay, but you can cancel the x plus 3 and the x minus 3, because when you multiply fractions together, you just make one giant fraction multiplying the numerators together and the denominators together. So you can just extend your fraction bar through the little multiplication symbol and have timesing going on. So the x plus 3 and x minus 3 cancel. And now we have a fraction that doesn't have fractions inside of it. Still not reduced yet though, right? Okay, so we can divide out an x from the denominator and reduce by x. So we have 6x over x times x squared plus 9. So 6 over x squared plus 9. So we end up with 6 over x squared plus 9. Does anyone have any questions? So method 2, you're just getting a common denominator in the little fractions. And then adding those or subtracting those. And then when you have one fraction on top and one on the bottom, you can invert and multiply. I think this next example we can work with method 1 though. So one more chance to use method 1. There is a sum. There is a sum in the denominator, but it's just the same sum in both denominators. So let's multiply all 4 terms by x plus 1. Okay, so you're multiplying the 2 and the little fractions and the 4 all by x plus 1. So the x plus 1 that you're multiplying by goes in the numerator, which I showed that for the 5. I guess I could have showed it for the 8 as well. So you're multiplying every single term by x plus 1. So that on the little fractions with x plus 1 in their denominators, those cancel. So you have 2 times x plus 1 minus 5 over 4 times x plus 1 minus 8. So that would be 2x plus 2 minus 5 over 4x plus 4 minus 8. So 2x minus 3 over 4x minus 4. And then always check and see if you can reduce. But if we factored off a 4, we still wouldn't be able to reduce, so you can leave it. So method 1 is usually for when you have a little simpler form, simpler denominator, or just one sum that's not too bad, and then multiply each term by that least common denominator. Let's just do one complex fraction that's really complex. So let's do this bottom one. So you have to use method 2 for these. Start in the bottom right. You have to use method 2, and you start in the bottom right and get a common denominator and add these up. So you're going to take the 2, and you want to subtract x over y. So you're going to build up the 2 by multiplying it by y over y. So you have the 1 off to the side, and then you have the 3 that you're ignoring. You're ignoring the 1. You're ignoring the m. But now you have 2y over y minus x over y. So these two little fractions now have the same denominator. So you can go ahead and do the subtracting there. So we're just following the directions on the right here, okay? So we have 2y minus x over y. So we're working in the bottom right, and we have now 2y minus x over y in the bottom right. So we keep working in this little complex fraction right here, and we flip over the 2y minus y over y, 2y minus x over y, and multiply times m. So we just keep working in the bottom right, and so you have that little complex fraction. So you flip the bottom fraction over and times it times the m. So now we have my over 2y minus x. So you're ignoring the 1, you're ignoring the 3, but now we have 1 plus my over 2y minus x. So now we repeat that cycle, the cycle of getting the common denominator and adding those two little fractions up. So we'll take the 1 and multiply it by 2y minus x over 2y minus x. The one in the denominator. So we're going to get a common denominator and add those up. And it is 25 after, so if you have to race across campus to another class, that's fine. You can look at this on video later when you're trying to work on it, okay. So we'll go ahead and add these up. So we have 2y minus x plus my over 2y minus x. So we're just getting a common denominator and adding the little fractions together, like method 2. And now we invert and multiply. So we flip that over times the 3. So we invert and multiply. So we have the 1 minus 3 times 2y minus x over 2y minus x plus my. So we have 6y minus 3x in the numerator. So we're almost there now. We just have to add 1 to this negative fraction. So we'll take the 1 and multiply by 2y minus x plus my over 2y minus x plus my. So the denominators have to match before we can subtract, but now they do. They're both 2y minus x plus my. So we have 2y minus x plus my, and then I'm subtracting 6y and adding 3x from a minus a negative 3x. And there's a few like terms you can add here. The 2y and negative 6y, that's negative 4y. And the negative x and positive 3x is 2x. And the my. So you start in the bottom right. You start in the bottom right and use method 2. Get a common denominator and add the fractions up, and then you can flip and multiply. When you do that, you have to get a common denominator and add the fractions up. Then you add them up, and you can flip and multiply. So we're doing the same steps repeatedly. Does anybody have any questions? Okay. I think I'll email back people. Some of you may want to look on Facebook if you haven't finished your homework, because then when I email students back, I usually post the answers on Facebook, so you can see the answers there. Okay, that's uwgb Adsit.
The extra credit's due today, right?
The extra credit is due today.